says this question use detail region. It says the graph shows x ln of x. Find the exact area of the shading region between the curve, the x-axis, and the line parallel to the axis through the minimum point. So this point here is the minimum point, through to the point where the x is equal to 1, which will be that point there. So what we are missing here is what that limit has got to be. Okay, so first we need to find the coordinates of the x-coordinate of the minimum point. So to find minimum points, you need to differentiate the function. So the function is y is equal to x ln of x. This is type uv, so we have to use the product rule. So that will be dy by dx is u, which is x, times the derivative of ln of x, which is 1 over x, plus v, which is ln of x, times the derivative of u, which is 1. The x's will cancel, so you get 1 plus ln of x. We need to put that equal to 0 for the minimum point. So we'll need to put 1 plus ln of x is equal to 0, which will give the ln of x is minus 1. X is going to be e to the minus 1 when you transfer that, or 1 over e. Right, now we need to find, so this is 1 over e, this is 1. So we need to integrate the shaded area. To find the shaded area, it will be 1 over e to the 1 x ln of x dx, and we'll do this by parts. So just drawing it out again, doing it by parts. Now you have to be careful when you've got ln by parts. You actually have to let u be equal to ln of x, because you can't really integrate ln of x directly. So du by dx will become 1 over x, dv by dx will be equal to x, and if you integrate x, you get x squared over 2. So just be very careful, because here it's slightly different. So integral u dv by dx is uv minus v du by dx dx. So we're going to have ln of x times du by dx times v, which is x squared over 2. And those limits from 1 over e to 1. Minus the limits from 1 over e to 1 of v, which is x squared over 2, times du by dx, which is 1 over x dx. So that will give me x squared over 2 ln of x from 1 over e to 1, minus the integral from 1 over e to 1 of x over 2. The x's here will cancel. So that will give me x squared over 2 ln of x from e to the minus 1 to 1. I think it would be easy if we just write this as e to the minus 1 when we substitute in. And then when we integrate this, we're going to get x squared over 4 from e to the minus 1 to 1. Okay, writing that out again. Okay, putting our limits in. So we're going to have 1 squared over 2 ln of 1, where ln of 1 is 0, so that's going to help, minus e to the minus 1 squared over 2 ln of e to the minus 1, minus 1 over 4 minus e to the minus 1 squared over 4. Well, this is 0. So here we're going to have e to the minus 2 over 2. And when ln of e to the minus 1, if you bring down the minus 1 in front, like you can do with logarithms, ln of e is 1. So we're going to have minus times a minus. So we're going to have minus e to the minus 2 over 2 times minus 1, minus a quarter, plus, because when you take that minus sign in, you get plus e to the minus 2 over 4. So this will be positives. So we're going to have one lot here, 1/2 and a quarter, which will make 3/4 of e to the minus 2, which is 3 over 4 e to the squared, minus a quarter. Now this is actually negative, because we would expect this area to be negative, but we're asked in the question to give the area, so we have to give the area as positive. So the integral is actually negative, but the actual area is positive, so we need to swap this around a little bit, factorize out. So it'll be a quarter minus a quarter minus 3 over 4e squared because we swapped these over the signs around, but you can take out a common factor of a quarter to get 1/4, 1 minus 3 over e squared. This has been a video for you to find a minimum point and to find an area underneath a curve. I hope you've understood, and I thank you very much for watching.